Ansible, agentless IT automation. Agenda, configuration management systems. Ansible history. Why Ansible? Playbook execution lifecycle. Getting started. Basic workflow. Playbooks and roles. Configuration management. Configuration management describes and enforces the desired setup of servers, so their state stays predictable over time. If a server drifts or gets misconfigured, you can simply rerun the same configuration to bring it back in line. Almost every team running more than a handful of servers relies on some form of configuration management. Any team managing infrastructure at scale needs a repeatable way to configure it. Yes, yes, that ink into servers by hand to fix things doesn't scale. Agent-based and agentless systems. An agent-based system installs and runs a background service on every managed node to receive instructions. An agentless system like Ansible connects over plain SSH and leaves nothing running behind afterward. Agent-based, Puppet, Chef requires an installed agent. Agentless, Ansible connects over SSH, nothing left running behind. Problems without configuration management. Single point of failure. The one engineer who remembers how a server was set up. Configuration drift. Servers slowly diverge as ad hoc manual fixes pile up. No repeatability. Rebuilding a server rarely produces an identical result. Slower to onboard new servers. Since every step is performed by hand, difficult to audit what changed on a server or roll it back safely. Misses out on version control, code review, and repeatable automation. Ansible automation system. Desired configuration is declared in YAML playbooks and kept in a source or Git repository. An inventory file lists the hosts a playbook should target. Grouped, however, makes sense. Ansible connects over SSH and runs each task's underlying module directly on the target host. Other similar automation systems, Puppet, Chef, SaltStack. Ansible advantages: agentless, needs only SSH and Python on the target. Nothing to install ahead of time. Speeds up repetitive server setup by turning manual steps into a reusable playbook. Human readable YAML makes playbooks easy to write, review, and share. Add important tasks mean rerunning a playbook is always safe. Huge collection of built-in modules covering clouds, networks, and packages. Integrate smoothly with CI/CD pipelines for continuous configuration. Everything is idempotent, almost. One huge benefit is that most modules only change what's actually out of the desired state. Running the same playbook twice in a row produces the same end result with no side effects the second time. Check mode lets you preview exactly what a playbook would change before it touches anything. Tasks report changed, OK, or failed. So you always know precisely what happened. A single control node can manage thousands of hosts without installing anything on them. Inventory and modules inventory. A plain text or YML file that lists the host Ansible can manage, grouped by role. Modules, reusable units of work that a task calls, like installing a package or copying a file. Playbook.yml. A playbook targets a group of hosts and lists the tasks that should run against them. Roles and handlers. Here, a handler restarts a service only when a preceding task actually changes something. History created by Michael D. Hahn and first released in 2012, building on his earlier work on Cobbler and Punk. The name comes from Frank Herbert's novel Dune, where an Ansible is a device for instant communication across space. Designed from the start to be agentless, using SSH and Python already present on most servers. Acquired by Red Hat in 2015, which continues to sponsor its development today. Now, one of the most widely used configuration management and automation tools in the industry. Why Ansible? Agentless? Nothing to install or maintain on managed nodes. Hosts. Simple, human readable YAML instead of a custom scripting language. Idempotent, safe to run the same playbook again and again. Declarative configuration, infrastructure and setup as version controlled code. Massive ecosystem, thousands of modules and community roles on Ansible Galaxy. Backed by Red Hat and a large open source community. Ansible.cfg and inventory. Ansible CFG lives in the root of the project and tells Ansible how to behave by default. Sets defaults like the inventory path, remote user, and SSH options. The inventory file lists hosts and groups so playbooks know exactly where to run. Keep secrets out of both files. Use Ansible Vault to encrypt sensitive values instead. Playbook execution lifecycle. Author.yml. Write it. Check with check diff. Apply Ansible playbook and review results. Verify. A playbook is written, previewed with check mode, applied to real hosts, and then verified against the expected result. Getting started with Ansible. This leads us to the three commands that get a playbook running. Ansible version. Confirm Ansible is installed and see its version. Ansible all -m ping. Verify connectivity to every host in the inventory. Ansible playbook. Run a playbook's tasks against the target hosts. Basic workflow. Author a file of inventory, script, playbook, check, and execute. Apply. Run, check, and tag a playbook. Some call run, check, and tag Ansible's everyday loop. Check mode previews changes without touching a single host. Diff shows exactly what a task would change, line by line. Tags let you run just one part of a large playbook when you need it. Add important tasks. Make it safe to rerun a playbook as often as needed. Supports many workflows, provisioning, patching, deployments, and compliance. Works the same across on-prem servers, cloud instances, and containers. Any questions? Thank you.